Hello my dear, I welcome you all in this session of Score Booster. I am Pragyabrat Tripathi. So the subject in this series, I already selected the subject of fluid mechanics. That means the fluid mechanics we will discuss, and also some part of the machinery. So this session is 2 days session for 3 hours, 5 to 8. That means today is 19th, 5 to 8, and 20, 5 to 8, and we'll cover all the important aspect around the fluid mechanics, and we will discuss, and also we'll discuss some part of turbo machinery also. Okay. So my dear, this is part 1. Basically, this is the part 1. So part 1 we have to discuss, okay, today. So what is that content part? See, this subject is important for both, as you know that this is important for both, for mechanical as well as civil engineering. So, and approximately in the gate it will be 8 to 10 marks. Civil it is less than, but this is according to mechanical. So mechanical approximately 8 to 10 marks, the gate questions will appear in the paper, and for the civil it is approximately 4 to 5 marks. 4 to 5 marks. In the civil there is also one topic is open channel flow, so that will also covered in the fluid mechanics in the gate paper syllabus. That is also included with the fluid mechanics. So that part also will in the civil 3 to 4 marks. So totally basics fluid mechanics and basic fluid mechanics and the open channel flow, it will be combined, and it will again 8 to 10 marks. So mechanical are also 8 to 10 mark, and civil engineering also 8 to 10 mark, including with the open channel flow. So what we have to discuss here, we discuss that we are from today onward, for 2 days we discussed this. I will discuss these things of the content part. What is that? First, introduction and properties of the fluid. Introduction and properties of the fluid. So in the introduction and properties of the fluid, the numerical which I will select, already I selected, the numerical part is the property. That means we have to discuss with the viscosity, the property of viscosity, and also some part of property like a capillary action, that means surface tension effect. So surface tension effect and viscosity we include this in this part, and then the fluid pressure measurement, that means there is a device, inclined tube manometer, inverted tube manometer, U-tube manometer. So will cover in this content second part. Then there is a hydrostatic force and buoyancy and flotation. Hydrostatic force and buoyancy and flotation. So there is some problem of hydrostatic force, how to calculate the hydrostatic force. Hydrostatic force calculation over the flat surface, and curved surface. I have numericals on that topic. Then buoyancy and flotation, I have also the beautiful questions. Then we will enter into the fluid kinematics. The fluid kinematics, I have a problem with the approach. That means many students have a confusion. Ki, sir, in the fluid mechanics, I have confused with the Lagrangian and Eulerian approach. How to identify the question it is given with, we have to solve with respect to the Lagrangian approach, or we have to solve with the Eulerian approach. So we will discuss in this kinematics part, and also we will to discuss the conservation of mass and conservation of momentum. So we will discuss the conservation of mass and conservation of momentum also in this case. Then there is a fluid dynamics. So in the dynamics we have to analyze the energy equation, and then there is a flow measurement device like a pitot tube, okay, pitot tube, venturimeter, orifice meter, like that. Then there is a dimension, very important. Dimension analysis is a very important topic for all the competitive examination, including gate. Then we have to discuss with the viscous, and these three viscous flow of incompressible fluid, flow loss in the pipe network, and drag. These are the advanced fluid mechanics. In this one we have to discuss the flow. So in the viscous flow, incompressible fluid, boundary layer concept. So this concept will include into 2 parts. One is the flow over flat plate, that means the fluid is flowing over the surface, that is called external flow, and then the fluid is flowing inside the pipe, inside the duct, inside the channel, that is called internal flow, and how to develop the boundary layer growth, and accordingly we have to discuss this problem also. Flowless and pipe network, we have to discuss with the Darcy-Weisbach equations, and also related to the problem of sudden increments, sudden decrement, okay. Okay, pronounced clearly. Okay. So viscous flow of incompressible fluid boundary layer concept. In this one, we have to discuss with the two cases. First is the internal flow, that means flow within the pipe, and there is an external flow over the flat plate. Clear this thing? Now, then we have to discuss with the drag and lift, the origin of drag and lift with respect to the boundary layer concept. So, according to the boundary layer concept, this drag and lift will appear into the picture. So, we have solved some numerical on drag and lift. Okay. Then there is a hydraulic machine, that is a turbine. Turbine we have to discuss in the last part. Okay. So, we'll start now, my dear. What is my approach? The approach is that we have to I am discussing the problem like that, so that according to the problem you have some concept also. With regarding of the problem, कुछ प्रॉब्लम के अनुसार आपके कॉन्सेप्ट को भी देखेंगे हम लोग. ओके, कॉन्सेप्ट को भी बिल्डअप करेंगे अलोंग द प्रॉब्लम. अकॉर्डिंगली उस तरह के प्रॉब्लम को हमने डिजाइन किया है यहाँ पे. सो व्हाट इज दैट? दिस इज द फर्स्ट प्रॉब्लम. दिस इज द फर्स्ट प्रॉब्लम बेटा, एंड वेरी सिंपल प्रॉब्लम. दिस इज योर फर्स्ट प्रॉब्लम एंड दिस इज वेरी सिंपल प्रॉब्लम. व्हाट इज दैट? डिटरमाइन द मैग्नीट्यूड एंड डायरेक्शन. सी माय डियर, shear stress. Okay na? This is your shear stress, my dear. This is shear stress. Okay, 1 second, I will increase the size of the pen. So shear stress, okay, shear stress and magnitude also, and also there is a direction that water applies. That means the shear stress by the water on the base and on the free surface. So my dear, just try it. I will give you a timer. I will give you time for okay. Just think for 1 minute. Okay, for 1 minute. Just think and reply in the comment box. Okay. Time is up. Now let's start the problem. Okay, so this is your base, and we know that the coordinate which we measured from the fixed surface, y is the coordinate which is measured from the fixed surface to the fluid. This is x direction, x is the flow direction, y is there. This is the velocity profile. Typically this is the velocity. So this velocity profile in which direction? X direction. X component of velocity which is varying along y, which is variation of y, So this is the profile. This is the velocity profile, and this is the free surface. So let's suppose this free surface, the velocity is free stream velocity, free surface. So this is free surface. So this profile it is given. This velocity profile it is given. H is the gap. H is your gap. So the question to find out the shear stress, at the base and at the free surface, Okay, let's start. So this is your velocity profile, it is given. Now this is your velocity profile. So we have to write like that. This velocity profile, it is visible. Yes, this velocity profile u, which is in x direction, variation in y axis, that is your u infinite, it is given to, please tell me, y by h minus y by h whole square. Simple problem, very simple problem. Okay, now my dear, we have to find the shear stress. So this is your surface, okay, this is our surface, and this is our x-axis. Obviously this is our x-axis, this is our x-axis. It is visible, okay, one second, we'll change the color of this pen. Okay, this is our x-axis and this is our y-axis. Okay, this is our x-axis, this is our y-axis. So my dear, the shear stress, the layer, it is like that. So the shear stress tau is what? First letter is your plane. So which plane it is? Y plane. Plane is the which is perpendicular. So y. Second is the direction x. So this is the notation. Why? Because shear stress is a tensor quantity of order 2. Stress is a tensor quantity of order 2. Vector is a tensor quantity of order 1. Scalar is a tensor quantity of order 0. So this is your stress is a tensor quantity of order 2, y and x. So according to Newton's law, we know that mu d x component velocity and variation along y-axis. We know this thing. Mu is the property of the fluid, dynamic viscosity. So first we have to differentiate. Why? Because we want this thing. We want this thing. So we have to integrate du x y by dy. Okay, we want this thing. Okay, so we have to find du over dy. So this is u infinite into 2 by h minus 2y by h square. This is the velocity profile. This is the velocity profile. Now put this value here back. So tau yx is equal to mu u infinite 2 by h minus 2y by h square. Okay, this is the shear stress. Now apply the condition. We are applying the condition. So what is the condition first? The condition is they are asking at a base, and at a base y is equal to what? 0. So tau yx at y is equal to 0. So if we put y is equal to 0, my dear, so this is what? 2 mu u infinite by h. 2 mu u infinite free stream velocity by h. So this is at a base and this is a positive. This is at a base. Who is applied? Who is applied? Water is applied to the base. What is the direction? Direction is very important, I am telling you. Who is applied? That means this shear stress is 2 mu and this is positive. That means this is applied by the fluid on the base. This shear stress applied by the fluid on the base, but what that water applies. So this water will apply on the base. On the base. So my dear, let's suppose we have to find the, so at the base this is your shear stress. So let's suppose, very important, I will identify the direction. This is very important. I will identify the direction. So this is your surface. This is your base. Okay. Now let's suppose this is a fluid element. This is a fluid element. Okay, no problem at all. This is a fluid element, and this fluid element want to move in this direction. This is a motion. This is a motion. So on the fluid element by the surface, on the fluid element by the surface, left side, and Newton's third law by the fluid element on the surface, right side. Okay. So this is a shear stress. So this green color is applied by the fluid on the element, and this is what a positive x direction. This is x direction, na? So see, this is a positive. So what is your answer? The answer, they are saying that magnitude and direction also. They are asking direction also. So be careful. So what is the direction we can write here? That means this is what beta? Tau yx at base due to the fluid is positive x direction, is positive x direction. Yes or not? Yes or not, beta? Please tell me. This is clear? Positive x direction. So the first option, the first to the base, what is to the base? To the base is 2 mu u infinite by h, and it is act in a positive x direction. Okay, done. Now the second part, to the free surface, very important. Please take your time and find it. What is the at a free surface? So my dear, at free surface, see the beauty, at the free surface, tau yx and y is equal to how much? This gap h, y is equal to h. So this is mu u infinite, and my dear, this is your expression, So if you put y is equal to h is cancelled, 2 by h was 0. That means what is the conclusion then? What is the conclusion? Please tell me, what is the conclusion? The conclusion is that, sir, this is the definition of the free surface. This is the characteristic of the free surface. What is that? At the free surface, there is no any shear stress. See, my dear, at the free surface, there is no shear stress. So, my dear, there are two things. One is called interface and second is called free surface. One is called interface, second is called free surface. Both have a different characteristic. Interface, that means two immiscible liquid, two immiscible fluid, and free surface, that means there is a one of liquid, other one of air. That is your free surface. That means, let's suppose this is your base. Very important. This is your base, and this is your free surface, and this free surface moving with the velocity u infinite. Okay. Now, if you draw the velocity profile, this is your y-axis. So it is like that. Yes or not? It is like that. It is like that. So this all a layer, these are the free, u infinite. These are the free. That means why this is called free? Why this surface is called free? Why? Because the fluid which is flowing over the surface does not feel the effect of wall. So that means there is no any messenger. To propagate the message. That means there is no any momentum diffusion. So in this one there is no any momentum diffusion. Yes, it is little bit, but no. So there is a inviscid. So above that there is no shear stress. So if you take this element here, if you take this element at the free surface, my dear, let's suppose you take the element at free surface. What is the mechanism? The mechanism is that, sir, at the free surface, this is a free surface. That means at the free surface, there is no any shear stress. So what kind of force will act? Only normal force will act. And generally it is a normal force. It is as an atmospheric pressure. So this is the free surface. So at the free surface, there is no any shear stress. Let's suppose, my dear, this is your free surface. So above this is what? Air. Let's suppose this is air. And below this what? Water. Below this what? water. Let's suppose this free surface is moving with the velocity of u infinite. So this water air will also move with the same velocity, and this is this is the boundary condition, no slip boundary condition. This is called no slip boundary condition. Both fluid move with the same velocity. Both fluid will move with the same velocity. Okay, at the free surface. So at the free surface, if this is a free surface, if you have any confusion, you can ask me. I am very happy to clarify your answer. Okay, so this is both have a same velocity. Both have a same velocity. So there is no free surface. That means there is no any shear stress. So there is no any question of direction. Clear? This is clear now. This is clear. So this is the concept of this question. This is the concept of this question. So in this question, we have to learn about what is the consequence of free surface, okay? And also we learn about that how to define the direction of the shear stress. How to define the direction. Okay, my dear. So before going to the next problem, I have one information. What is that? In the IMS, there is a benchmark yourself against the best throw. Test series plus. There is a test series plus. So if you have, and this test series plus is made by the IITs and alumni. They're very good test series. And test series is a level 1, level 2, and level 3 level. So what that 130 plus online test series is there. 130 plus, and in that one 33 year GATE PY cube technical subject ka. Technical subject. And so if you right now if you join, you get a 20% of test series plus. And in this one, what we have to include a 33 year GATE PYQ technical subject. That means beta, and in this PYQ, very unique PYQ, and in this PYQ there is a QR code. So if there is a toughest problem is there, and while you are learning the questions, while you are reading the question or try to solve the question, you have a difficulty, you just scan the QR and then you have to find the lecture, okay? And then also 33 year PYQ of math and general knowledge. So my dear, there is a very important, these two are separate book. It is not included in the same book. There is a technical other book, and there is a 33 PYQ math and aptitude other book. So you have to got two books. And doubt solving portal is there, LMS, and online reservation and score booster, okay? Revision, online revision and score booster. There is online revision also and score booster. Post GATE guidance you have to find, and also there we have to provide the mock interview. If you selected in written examination, then after you have to face with the then your the second criteria is for interview. So that will also prepare by this thing. And if you have, and no more link description given. This is the link description, you can check with that. Okay, now next is that, see my dear, there is a GATE 2000, if you join the GATE 25-26 live online program, so what you have to benefited, so program feature is what, 800 plus hour live classes with a live introduction, theory book, exercise book, and in that one there is a 4000 plus question is there, and there is a 33, this is not 34, 33, okay, 33 year of GATE question bank with a video solution, already I have told you. 12 personal one-to-one mentorship session is there, 12 personalized one-to-one mentorship session is there, directly with student and teachers will communicate with each other, and 130 online test series with a video solution of a mock test and many more. Now my dear, if you want to have a free counseling, you can, free counseling session, click this link below, or you can call directly, okay? Now, so this is done. Little bit information I want to share you, that is done. Now come with the problem. This is best problem. Now I will increase the level, little bit. I will increase the level, and each and every question don't try to solve to find the answer. No, inside the concept. So first problem, free surface concept. Second one, there is also very good question, and I hope somewhere you have to find this problem. So what is that? A viscous Newtonian liquid film falls under the action of gravity. My dear, I will give you one information. See, throughout the fluid, in the world of the fluid, the motion of the fluid, the trigger of the motion of the fluid by three mechanisms only. By three mechanisms, you can flow the fluid. What is that first? First one is the displacement of a boundary. That means there is a table. On the table, there is a water. And now you want to move the water, remove the water on the table. What you have to do? Put the cotton, drag the cotton. Put the cotton, drag the cotton. So during that, the fluid is flow. So that fluid is flow is not due to the pressure, or not due to anything. That fluid will flow. That is the displacement of a fluid boundary. That is called. And this features will appear in the Caught flow. What is that? Caught flow. Number second, if the flow within the channel, that means there is a pipe, and if we want to flow in this pipe, what we have to do? We have to change the pressure. That means high pressure to low pressure. That means within the pipe, within the closed duct, the fluid will flow through the pressure. And third one, due to the gravity. So this fluid is flowing due to the gravity. So there are only three mechanisms to flow the fluid. One is the displacement of a boundary. Second one is the due to the pressure difference. Third one is the direction of gravity. Direction of gravity. Okay. So this is the gravity flow. This is not a pressure flow. This is the gravity flow. What is that? See, this is your viscous falls under the action of gravity down the surface of the rod as shown in figure. See, my dear, this is your rod. This is your rod. Like that. This is your rod. Okay. 1 second. This is your rod. Yes, this is your rod, है ना? ये rod है आपका. This is your rod, and this rod is a rod, and there is a fluid will coming. See, this is very physical phenomena. This phenomena is very practical phenomena. So what is that? If this is a rod is there, and now let's suppose you have a cane of a soft cane. That means cold drink cane, chilled cane. Put the cane inside the room. After some time, on the cane there is a fluid layer, and that layer will drag down, and that drag down of the layer is due to the gravity. So like that, this is there. This is the cylinder. Over that, the film is there is a fluid film. So that fluid film is like a annular. That means this is inner and there is an outer cylinder. So this is an inner cylinder, and over that there is a film, and that fluid film will glide over the surface due to the gravity action. So this is the case. Okay, now this is the direction of Z. It is given. This is the direction of Z, and this is the radial direction. The rod of a radius A and the film radius is B. It is given. The film radius is B, rod radius is A, and this is your radial direction, and this is your Z direction. Axial direction, and this is your radial direction, and fluid will flow like that. The fluid is coming. It is like that, my dear. It is like that. Fluid will come and it will flow in a film type. Okay, now, and my dear, the velocity distribution it is given. Now, my dear, see from this one, the velocity distribution is not a linear. Velocity distribution, not a linear. Velocity distribution is a radial, parabolic, square. It is a parabolic. So it is a not linear. Though generally a student get confused, sir, this is a very thin layer. So the velocity profile is linear. No, we have assumed like that. But this is your velocity profile. It is given. In the question, it is given. Now, my dear, this velocity is what? What is the profile? Velocity in which component? Which component velocity? Fluid is flowing. Z component velocity. Variation, radial direction. Yes or not? This is the velocity profile. Velocity in Z direction. Variation it is in R direction. This is done. Okay, so this is given. This is given. Okay, velocity profile is given. Now, where rho is the density of the liquid, G is the acceleration due to gravity, mu is the dynamic viscosity, A is the radius of rod, B is the radius of the free surface. Okay, that great. This is also a free surface. If there is a cylinder is there, if this is a cylinder and film is flowing down over it. So outer layer of the film is behave as a free surface, no problem. So this is your free surface. This is your free surface. This is your free surface. Okay. So what you have to find, what is the shear stress at the free surface of the liquid? Simple. What is the value? 0. We will prove again. What is the shear stress at the free surface? Obviously it is 0, but we will prove it, no problem. Now the second part is important. What force act on the rod? That means, see my dear, if the fluid is falling down, so the fluid will exert a shear stress on the rod. When the fluid is falling down, the fluid will exert, that means they try to pull the rod downside. So what is the force to try to pull the rod downside? And that force is, what is the origin of that force? Origin of that force is the viscosity. So there is a viscous force, and that viscous force will create a drag. So there is a drag force per unit length of the rod to the viscous liquid. Okay. Now third is, we have to find the discharge. You don't find the discharge, only you have to set a formula in the integral form. Clear? So this is the complete knowledge about shear stress, drag force and discharge, how to calculate. Please keep in mind, baseful mind. I will give you just 1 minute to think, my dear, so that I will give you 1 minute and just think, beta. Oh, 1 second. 1 second, my dear. Just I will give you 1 minute. Okay. Start, my dear. Okay, we'll keep it is anywhere. Oh. Okay, just start. Think that. Okay, so time is voice quality. Yeah, voice quality, increase the voice quality. जो मिल रहा है वही से पढ़ो बेटा, है ना, ऐसा नहीं है. Voice quality clear, रोज लेता हूं मैं क्लास. Okay, now अब देखो. So now just find it. Okay, just find it. Okay. Okay, so this is your profile, this is your arrangement. Now वॉइस की जरूरत नहीं है, आपको पता है, तो आप बनाइए क्वेश्चंस को. ओके, नो प्रॉब्लम. डिस्टर्ब मत करो बेटा, आप डिस्टर्ब ना करें. सो ओके, दिस इज योर रोड. ओके, दिस इज योर रोड एंड देयर इज अ फिल्म. नाउ दिस अगेन, this flow with the help of gravity. This film will flow with the help of gravity. Now my dear, and this says that this is a free surface, yes or not? This says that this is your free surface, yes? Free surface. Free surface. Okay, this is your free surface. Now this is a velocity profile. So what we have to do, we find the shear stress. What is the direction of shear stress? How to notation of the shear stress? Please find it. What is the notation? Tau. बोलिए, अरे बोल. Tau. बोलिए. Tau. यहाँ क्या लिखूं मैं? Please. यहाँ पे क्या लिखूं? ये जरूरी है. What is that? Tau. Which plane? Which plane? अरे बोल. Which plane? Shear stress. This is shear stress. So which plane? R. So there is R. Which direction? Z. Tau rz. So we have to find tau rz. So the velocity profile it is given. Now we have to find tau rz. So first A, tau rz, we have to find free surface of the fluid. Free surface of the fluid. We have to find free surface. We have to find the shear stress at the free surface of the fluid. Okay. Now, at the free surface of the fluid, one second, yes. So, my dear, what is tau rz according to Newton's law? Mu du. Which component velocity beta? Z component. And variation it is in r direction divided by what? Dr. What is that? Dr. See one thing. What is that? See that, beta. You know the boundary no slip boundary condition. What is that? See, this fluid here, the fluid is flowing downward. Yes or not? The fluid is flowing, free stream, fluid is flowing. Now, at this point, if you take this radial distance, if you take this is your radial distance r, so beta, at this point, the velocity is the free stream velocity. At this point, what is the velocity? 0. Why? Because this rod, it is at a fix. It is not moving. So, at this point, there is a velocity 0. And if you draw, there is a velocity parabola. This is the velocity distribution. This is the velocity distribution. That means velocity will distributed along this. So, which velocity component? Z component. Which direction variation? R direction variation divided by R. Now, so mu, if you differentiate this thing, beta, differentiate. So, this is your minus rho g by 2 mu into R plus rho g b square divided by 2 mu into 1 by R. You just differentiate it. Okay. So, what is that, beta? This is the shear stress acting on the fluid element, but at the free surface. But we have to find that at a free surface. So, this is the shear stress acting by the fluid element. So, this is the shear stress tau rz. So, this is the shear stress acting by the fluid. Now, we have to find the shear stress at the free surface. So, what is the R? What is the R, beta? R is equal to B. So, at free surface, R is equal to B. Put R is equal to B. So, tau R Z at R is equal to B. If you put B, so this B cancel, this is B, so this is 0. 0. See, again this is 0. That means this is a free surface. So, free surface, there is no shear stress. Okay. So, that is complete. This is a what is the shear stress at the free surface of the liquid? That is 0. Okay. Now, second, very important. What is the force? What force acts on the rod per unit length of the rod due to the viscous liquid? So, my dear, there is a fluid is viscous. So, due to the viscous, there is a resistance, and that resistance is what? Viscous resistance, that means viscous force, and that force will produce a viscous shear stress, and that viscous shear stress will try to drag the plate, drag the rod. So, what is the drag force per unit length, they are asking. Okay. So, my dear, we have to find the drag at this, very important. We know that when the flow over a surface, Very important. This is internal flow or external flow? Please tell me. This is internal flow or external flow? This is external flow. That means flow over the rod. This is your rod and flow over the rod. So this is external flow. And my dear, external flow, if the flow is externally, the shear stress continuously decreasing along the flow direction. We know that. The shear stress is continuously decreasing. That means here maximum, again here minimum, again here minimum. So it will continuously varying. And in the flow direction, it is minimum. Why? Why minimum? Just think why it is minimum. But the shear stress in the flow direction, it is a minimum. So if we'll start the flow from here, so if the flow is moving down, 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 leading edge to trailing edge, so its shear stress will continuously decreasing. Why? Just think, okay? Now, so we have to find first the shear stress, and that shear stress is continuously varying. So my dear, let's suppose this is your rod. So this is your rod, okay na? This is your rod. See this thing, where we have to draw, okay. Okay, no problem, we'll do that. Okay, so my dear, this is your rod. Now see this thing. If you cut this rod, and make a flat plate, So if you cut this rod, stretch it. So there is a rectangle. So on this rectangle, so this is like that. This is on the road. Okay. This is like that. This is like that. Now my dear, what is this area? This one. What is this length? First tell me. What is this length? 2 pi into A. So this is 2 pi into A, 2 pi R. And this length, let's suppose Z. This is your Z. Okay, this is your Z. And this is your what, beta? This is your plate. This is what? Rod. This is a rod in a plane. Now my dear, if the fluid is moving, this is shear stress. It will continuously decreasing. So these are shear stress. This is shear stress continuously decreasing. So how to, why? Because we have to calculate the force. So for the calculating of force, stress is what? Force upon area. So we have to calculate the shear stress. But here shear stress is differ. Here the shear stress throughout length is differ. So how to calculate the shear stress, total net shear stress? First we have to, this is the concept. This is a very important concept. How to calculate the net total shear force? Why? Because shear force is continuously varying. So how to calculate the model? The model is that you just take a elemental part. Just take an element. Why you are taking element? Why? Because we have to take just, this is the mathematical model. You take a just elemental so that in that element the shear stress variation is negligible. Why? Because shear stress is varying from this point to this point. But if you reduce this area very minimum, so we can treat it as a constant shear stress at this location. So let's suppose this is your dz. This thickness is dz. And over that the shear stress is, let's suppose over that shear stress is tau. Shear stress is tau. So my dear, this area, why? Because if you calculate the shear stress, we have to find the area. So what is this area? This area is what? 2 pi A length into dz. That means 2 pi A into dz. This is the area, shear area. Yes or not? Now, so we have to find shear stress. That means tau R Z, and this is at what distance, beta? This is at what distance? A. R is equal to A. R is equal to A. So this is your mu. Put R is equal to A here. Put R is equal to A here. So this is your mu minus rho G A divided by 2 mu plus rho G B square divided by 2 mu A. Put this value, beta. Put put this value in this one R, and there is R. What you have to put? A value, A. So this is your required condition. Now, so in this one there is a shear force tau in this area dA. So the small shear force is equal to tau, obviously, which is a function of Z, into d shear area. Yes. Okay. Now what is DAS? 2 pi A dz. Yes or not? So my dear, this is what? This is what beta? Force. So this is a force act due to the viscosity divided by dz. Why? Because they are asking per unit length. So this is what beta? Force by, it is visible, na? Force by length. Force by length. And what is this one? Tau, which is function of z, 2 pi into A. 2 pi into A. Now my dear, okay, so force per unit length is equal to tau. This tau is what? This one. Hai, this one, R is equal to A. So tau into 2 pi A, again 2 pi A. So this is your tau R Z at R is equal to A into 2 pi A. Now this you have, this value you have here, put this value back here. So if you put this value and rearrange, this is your rho G pi square A square into B by A whole square minus 1. This is your force, this is your force per unit length. This is your force per unit length. That means drag force per unit length, skin friction drag. This is your skin friction drag. So this is your, this value. Now my dear, this is in which direction? Downward. So this is your downward. Direction is, this is your downward. This force is downward. Clear? Clear? So my dear, this is a simple thing. Now I will discuss one thing very important. Very, very important. What is that? See. See. This one. This is your free surface, yes or not? See this thing, beta. Very important. This is your rod surface. Yes or not? This is your rod surface. And this rod surface is fixed. This rod surface is fixed, let's suppose. Okay. And this is our fluid element, yes or not? This is our fluid element, let's suppose. And this fluid element, let's suppose this is at the free surface. Yeah, near the, let's suppose there is a, here. We have to select this fluid element here. 1 second. You have to select this fluid element here. There is a fluid element like that. You have to select this fluid element here. Okay, so these are the fluid element. So this fluid element is there. Now my dear, and this is our free surface, yes or not? See, this is our free surface. It is like that. Yes or not? This is our free surface. Free surface. If you draw, then draw, no problem. This is our free surface. So at this free surface there is no any shear stress, but this element want to move down due to the gravity. So there must be a weight. There must be a weight downward. There must be a weight downward. There must be a weight downward. Through this weight it will move down. So that weight is your W weight. Now how many forces? This will move down. So on this surface, in this direction, there is a shear stress on the fluid element by the wall, and by on the wall, this is the direction of the, this is by the fluid on the wall, this is by the fluid on the wall, this is by the fluid on the wall, this is the weight. Now please tell me, there is one force more. Please tell me. Please tell me. There is one force more. There is a fluid element which is at the free surface. So at here there is a no shear stress. Okay, but this fluid is want to move down. So there is a drag. So it will exert. This is your rod. This is your rod surface. This is your rod surface. This is your weight. And this is your shear force. This is your shear force. So this shear force, weight, and there is one force more. Please tell me. Bolo bhai, bol. Please tell me. One force more. Buoyancy. What is that? Buoyancy. Why? Because this, there is a density difference. This is, if you move down, so let's suppose there is a very chill. So there is a density difference, and buoyancy will act always upward. So upward direction there is a buoyancy. Upward direction there is a buoyancy. Upward direction there is a buoyancy. So in this direction there is a buoyancy effect, FB. FB, there is a buoyancy. So this is the net force on this element. This is the net force on this element, buoyancy force. So FB is your buoyancy. So shear force, this is your shear force, your drag force on the fluid element, or drag force on the fluid element which is upward, which is direction is upward. Weight of the fluid element which is act downward, and there is a FB which is buoyancy force which is upward. Yes or not? Buoyancy force which is upward. Okay, so these are the forces will act on this fluid element. Keep in mind. Okay, these are the concept. These are the concept. Okay. Now, the next part is discharge. The next part is, see, setup. That means you are set up, but don't solve. There is a lengthy, so don't solve. The integral of determining the volume flow rate of the liquid flowing down to the rod. What is the volume flow rate? See. What is the volume flow rate? What is the volume flow rate? Okay. So see, my dear. See this thing. See, my dear. This is your outer periphery. If you see from top view, there is outer periphery. This is your outer periphery. This is your outer periphery, my dear. This is your outer periphery. And this outer periphery of radius R. What is that? Radius R is equal to B. Okay. And there is inner periphery, inner which is solid. There is inner which is solid, beta. There is inner core which is solid. The inner core which is solid. So there is inner, and this inner it is your solid. This inner it is your solid, my dear. Yes or not? This inner it is your solid. Now my dear, the fluid is, this is what my dear, free surface. Yes or not? See, this is over that there is an annular shape, free surface, and there is a rod surface. Okay. Now, in this one, the fluid which we try to enter. Now, my dear, what is the discharge? What is discharge, my dear? Q is equal to area. What area? Cross-section area into velocity. You know this. This is what velocity? This is your average velocity. Average velocity. And this average velocity is uniform. This average velocity is uniform. Now, my dear, see this thing. But in this case, this is your radial direction. Yes, this is your radial direction, my dear. At this point, the velocity is 0, no slip condition. At this point, there is a free stream velocity and there is a parabolic nature. Yes or not? So, velocity will continuously differ. Velocity from the rod surface to the free surface continuously changing. So, there is a problem. We are not applying directly this formula. Why? Because we don't know the velocity, and the velocity which is given, that is variation with respect to art direction. So, my dear, what is that? If you draw this one, if you draw, my dear, so 1 second, okay, no problem. Okay, so okay, done. Now, this is a free surface. The velocity is the free velocity. Free velocity. Here the velocity is 0. Why? Because rod is, and the profile is parabolic. Profile is parabolic. It is like that. So, this is a profile, velocity profile. This is our velocity profile. This is our velocity profile. Now, my dear, the velocity profile will vary from 0 to, that means r is equal to b, r is equal to a, to r is equal to b. The velocity is continuously changing. So, this is your r is equal to a, and this is your b. So, r a to b, velocity continuously changing. So, my dear, what you have to do? Same. We have to select an elemental ring. Over that ring at a fixed radius. So, if the radius is fixed, velocity is fixed. So, we have to take a ring. This is the model which I am telling you. Just think like that, okay? So, there is a ring. We have to select a one ring. Okay, you have to select this ring. Okay, and there is another ring, elemental ring. Okay, you have to select this elemental ring. This elemental ring, my dear, and this is like that. You select a ring. Through this ring, the velocity is entering. So, let's suppose this is your gate. This is your gate. It is like that, in which the velocity is u, which direction? Z direction at radius r. At radius r. So, you have to take this ring at radius r, and thickness is dr. So, if we have to take the r radius, that r radius, the velocity uz r. So at r radius, and then you have to integrate from r is equal to a to r is equal to b, and then you have to find the discharge. Clear now? That is the concept, basic calculation of fluid mechanics. Okay. So so in this one, dq discharge is your cross section area is what beta? First volume of velocity uz at a fixed radius r into what is the area, cross section area? 2 pi r dr. Yes or not? So from here, if we find total discharge, just take 2 pi r common, 2 pi outside integration, and there r is equal to a to r is equal to b u r dr. So this is your required expression of discharge. Clear na? This is the required expression of discharge. So all the things is completed in this question. All the things. What is the shear stress at the free surface, and we have to discuss with the how to calculate the drag over the rod, and then we have to balance this. This is very important thing. Then we have to balance this, particularly who are a mechanical engineer, engineering background. It will appear in the heat transfer, and that is your film condensation. Film condition is there. So there is a film condition in that chapter. So on that chapter we have to balance this force. So that is the concept. Okay. So then we have to find the discharge and how to find the discharge. Clear? Clear everyone? Please tell me. This is clear or not? Please tell me. Okay. This is clear now? Now we will take the next problem. Yes or not? Are you ready? Next problem. Okay. What is that? Yes, this is also very good problem. Yes. So let's try this problem again, and I will give you again a timer for 1 minute. Start. Time up. Okay. Let's why all the questions जो हमने यहाँ पे रखा है, all questions जो हमने यहाँ रखा है सब intuitionally रखा है, क्योंकि बहुत सारे books में, बहुत सारे PYQs में these questions are the explanation of these questions are very wrong or very lengthy. Okay. Now see this thing, a cylinder of 0.12 meter radius, there is a cylinder, this cylinder is that, and this cylinder is 0.12 meter radius, rotates, this cylinder is rotating concentrically inside the fixed hollow cylinder. So outside is a fixed hollow cylinder, and that have a radius 0.13 meter. Both cylinders are 0.3 meter long, these cylinders are 0.3 meter long. Determine the viscosity of the liquid which fills in the space between the cylinder if the torque is, and then you have to apply a torque of 0.8 Newton meter is required to maintain the angular velocity of 2 pi radian per second. That is your question. Okay. Let's try to solve this question. So what is the moral of this question? Moral of this question is that we have to find the viscosity property. We can find this arrangement. This was a viscometer type of these things, and we have to apply this torque and to maintain the angular velocity constant. To maintain this angular velocity, that means we maintain this angular velocity. How to maintain this angular velocity constant, beta? Please think this thing. So there is a rod which is moving. Over that there is another cylinder. There is one cylinder which is moving. Over there is another cylinder which is rest, and in between that there is a fluid. Now, when you have to give the torque, this one, you are applying this torque. Yes, yes. That means if space between the cylinder, if torque of 0.18 Newton meter is applied, that means there is applied torque. So you applied this torque 0.8 Newton meter. The viscosity, due to the viscosity, there is a viscous force, and due to that viscous force, there is a viscous torque. So that torque will resist this torque. So this is applied torque, and one torque will produce due to the viscosity, and both are in opposite nature. And if these two torque, that means one torque is due to the viscosity and other torque which is applied, if both are balanced, in that case the angular velocity is constant, maintained. That is the simple things. So applied torque is equal to viscous torque. Applied torque is equal to viscous torque, so that the angular velocity will maintain. Angular velocity will maintain. Okay, done. So let's start. Okay, let's start, my dear. So this is your cylinder. We have to draw the cylinder first. So my dear, this is your, let's suppose this is your outer cylinder. Okay, and let's suppose there is inner cylinder. Let's suppose this is your inner cylinder. Okay, this is inner cylinder. There is a axis of rotation. There is, my dear, axis of rotation. This is your axis of rotation. Okay, this is your axis of rotation. In between that there is a fluid. In between that, my dear, there is a fluid. Okay, so in between that there is a fluid. This is your fluid. In between that there is a fluid. Okay, this is your fluid, and the outer cylinder is fixed. The outer cylinder is fixed, and the inner cylinder is rotating. Inner cylinder is rotating. Outer cylinder fixed, inner cylinder rotating, and obviously this is your axis of rotation. Axis of, this is your axis of rotation. About this axis, the cylinder, inner cylinder will rotate. Now my dear, and here we have to apply the torque. How much torque you apply? 0.88 Newton meter. This torque is applied, and the angular velocity, it is your 2 pi radian per second. This is our angular velocity, 2 pi radian per second. This is our angular velocity. Now this is your applied torque. Now my dear, this is your fixed cylinder. So if you draw, very important, I'm telling you, maximum student confused here, I'm telling you. Please solve, otherwise there is a very problem. I know that, as a teacher I know that. This is your outer cylinder. This is your outer cylinder, my dear. Okay. This is your outer cylinder. This is your outer cylinder, and there is inner cylinder. There is your inner cylinder. Okay. This is your inner cylinder. This is your inner cylinder. Okay. Now this cylinder, now my dear, see this thing. This cylinder, outer cylinder is fixed. Outer cylinder is fixed. One second. This outer cylinder is fixed, and this inner cylinder is rotating. this inner cylinder is rotating. Let's suppose it is rotating in a clockwise sense. It is rotating. Now, so this, if to rotate this cylinder, we have to apply this torque. So there is a torque is applying in this direction. Very important. This is your torque applied, which is given T, and this T, it is your 0.88 Newton meter to rotate this angular velocity omega. Okay. Now, but this torque which is applied will resist by the fluid which is present inside the gap. By the fluid which is present inside the gap. So it will produce a viscous torque which is opposite in nature of the applied torque, and if both are balanced, this angular velocity maintain constant. Okay. Now, if you draw the velocity profile, this is rotating. If you draw the velocity profile, this is fixed. This is your velocity. It is like that. This is your velocity profile. This is your velocity profile. So this velocity profile, it will varying from inner radius Ri. This is your radial direction R, and this is your Ri, and this is Ro, outer radius, and both radius it is given. Both radius given. This is applied torque. Applied torque. My dear, here it is given to maintain an angular velocity 2 pi, that is fixed. So to maintain the angular velocity, the applied torque is exactly equal to the resistive torque, a torque due to the viscosity, so that the angular velocity maintain constant 2 pi. That is the model. So to maintain, write down, to maintain constant angular velocity, to maintain this constant angular velocity, what you have to do? The applied torque is exactly equal to the viscous torque. Applied torque is exactly equal to the viscous torque. And this viscous torque, who is the responsible? This viscous torque, who is responsible to the viscous force? Viscous force. This is your viscous force. So, my dear, what is the viscous force then? What is the viscous force? See this thing. What is the torque? Viscous torque. See this thing, beta. What is the viscous torque? Viscous force into arm length at any r. And my dear, this viscous force, very important. This viscous torque will differ at each and every r location. At each and every r location. So if r will change, let's suppose at any r, this is r. So at any r, this is a viscous force, and this viscous force is varying according to r. So if r will increasing from this axis of rotation, so the viscous force will also increasing from inner to outer. So this is a viscous force, and my dear, this is r is what? This r is what? This r is your at any radial location, any radial location from axis of rotation. Axis of rotation. So if you find the shear stress, viscous shear stress, so this viscous force divided by area, shear area. In this sense, what is the viscous force? Why? Because if you find viscous torque, first we have to find the viscous force. How to find the viscous force? We have to find the viscous shear stress. How to find viscous shear stress? Newton's law of viscosity. So viscous force is your viscous shear stress into shear area. Okay, this is area. And what is this area, beta? What is this area? Please tell me. What is this area? This is the, see, this is the cylinder. So this is the area over which the shear force will apply. This is the area. This is the area. And what is this area? What is this area? 2 pi r into length. 2 pi r into length, that is the area. Perimeter into length. 2 pi r is perimeter into length. Over that the viscous, over that this is the viscous, over all the surface. Why? Because it is rotating like that. So over that all the viscous shear stress is there. So this is what? This A is what? 2 pi r, and L is the length. This is length, and it is also given length, it is given. This is length. Okay. Now, so this is the story of viscous force. Once you have a viscous force, you can easily calculate viscous torque. So now there is a one thing, and there is another thing also very important. Second thing you can think like that. Second thing. What is that, my dear? If you find the viscous force, viscous shear stress, there must be a velocity gradient. And velocity gradient always measure from the fixed surface. So my dear, if this is the cylinder and this is not a fixed surface is this one, upper cylinder. So let's suppose you have to cut it, stretch it. So this inner cylinder, cut it, stretch it, keep at the center. Keep it is at center. Outer cylinder, keep at this position. So my dear, okay, done. So let's suppose this is a cylinder, outer, this inner cylinder, and this is your outer cylinder. In the plane, in the plane of that limb, it is like that. This is your outer cylinder, and this is your inner cylinder. This is your outer cylinder, and this is your inner cylinder. And the gap, let's suppose this gap is your h. This gap is your h. Let's suppose this gap is your h. Now, my dear, this r is what? This r is what? Radius from inner axis of rotation. So let's suppose this is your axis. This is your axis of rotation. Axis of rotation. So from this one there is a r. So r is at any, let's suppose this is any distance r. And y is what? Always from the fixed surface. This is y. Yes or not? And there is any layer which is at radius r. Which is at radius r. So my dear, what is h? R plus y. So if we find dh is equal to dr plus dy, and this h is constant, this h gap is constant. This gap is constant. So this is 0. So what is that? dy is equal to minus of dr. Clear na? So if you find the shear stress, applied torque is how much? 0.88. What is the viscous torque? Viscous torque is what? Viscous torque is tau v into as. That means this is your tau, viscous shear force, viscous stress, into area is what? 2 pi r into L. Yes or not? And this is a torque. Multiply with the arm length. This arm length is r. This is a torque. Okay. So if you rearrange this one, put all this value here. L is what, beta? L is what? L, it is your 0.3. Put all this value L, R, R. So we have to find viscous force. The relation is your 0.467 divided by R square. See the beauty. See the beauty. Okay, na? What is your observation? Sir, observation is that the viscous shear stress is varying parabolically. Yes or not? That means if R will increase, this viscous shear stress will decrease. That means from the axis of from the outer surface of the inner cylinder, from the outer surface of the inner cylinder, from the outer surface of inner cylinder to the outer cylinder of inner surface, the viscosity continuously reduce in the radial direction. The viscosity is continuously reduced in the radial direction. So someone asks you directly, what is the viscosity? There is a variation. Where is the maximum? So maximum at where? Maximum where R is minimum. So R is minimum at the inner cylinder, and R is maximum at the outer cylinder. So from inner cylinder to outer cylinder, viscosity will increase. That means decrease. That means from R is equal to Ri to R is equal to R naught, this viscosity continuously reduce. This viscosity, viscous shear stress is continuously reducing. The viscous shear stress is continuously reducing. This is the concept. Now, we have to find what is that viscosity, coefficient of viscosity. Now, my dear, this is done. Now, we have to apply this is what? Tau. So, viscous torque is what? Mu du over dy, this one. We know that from Newton's law of viscosity. That means this du over dy is what? Du over dy is what, beta? Tau divided by mu, okay na? And tau is what? 0.467 divided by mu r square, yes or not? Mu r square. Now, so this is du over dy. Now, my dear, instead of y, we have to put minus dr. Why? Why? Because viscous shear stress is the function of radial direction. Radial direction, and radius will measure from the center. Okay, so this is a relation. That means if you put du, that means du divided by minus of dr, and that is equal to 0.467 mu by r square. 0.467 divided by mu by r square. Yes or not? Now there is a simple things. So du separate minus 0.467 divided by mu r square into dr. Now we have to integrate this du, lower limit, minimum. Where is the minimum velocity? Please tell me, where is the minimum velocity? Limit is minimum to maximum. Where is the minimum velocity? Outer. So V outer, obviously it is 0. So V inner, and this is maximum, and that is equal to minus of 0.467 constant divided by mu constant, integration dr by r square. So V outer is what? Outer velocity RO, and that is given 0.13. Inner Ri, and that is given 0.12. Now very simple. Now, my dear, so this is what? V inner minus V outer, and if you solve this one, this is 0.467 divided by mu, और यहाँ पे आप लिख दीजिए ऐसे 1 by r 0.13 to 0.12. Okay. Now this is what beta? 0. Outer is 0. Why? Because fixed. Outer is what? Fixed. Outer cylinder is what? Fixed. Now inner is there. Inner cylinder is there. Now from here, what is inner velocity? What is inner velocity? V barabar r into omega. So r inner into omega. Yes or not? So r inner is what? 0.12. Omega is what? 2 pi. So this is how much? 0.754 meter per second. So this is your inner velocity. Put this value here back. So 0.754 is equal to 0.467 divided by mu into 1 by 0.12 minus 1 by 0.13. Only mu unknown. So mu is equal to 0.397. What is the unit? Pascal second. Clear? Clear, beta? And this question also in many books there is wrong. I am telling you. And this is the best method. Other method, what you have to apply, क्या आप इस method पे apply करते, what you have to apply this method, other than this one, that is difficult. So this is the very basic concepts. All the things here. So there is one thing is that how to convert a y direction into the r direction. Both are always opposite. Okay. So this is done. And what is that? Viscous torque. What is that? Viscous torque. We already discussed viscous. To maintain the constant angle, applied torque is equal to viscous torque. It is clear, beta? Everyone, please tell me. That is clear, na? So this is the question related to the property, one property, viscosity. So my humble request is that please try to solve such type of questions. Okay? On the textbook, any textbook you have to follow, no problem. Any textbook, try to solve this kind of problem. This kind of problem you have to try to solve this kind of problem. Okay? So now the next problem is, see, this is also, and this is the next problem is your action of capillary, that means surface tension. Application of surface tension. There is one application of surface tension is capillary action. This is also very good problem. See this question. The end of capillary tube with radius r. The end of capillary tube with radius r is immersed in water. Assuming that the tube is to be sufficiently long, sufficient long है, बड़ा tube है. Calculate the heat energy produced. लो, ये क्या पूछ दिया भाई? Calculate the heat energy produced when the water rise in the tube. Why? Because during the capillary there is a capillary action and the fluid will flow. Fluid will be rise from low level to, in the capillary there is a rise. So it may be rise, it may be decrease, but this is a water. So water, it is a wetting fluid. It is a wetting kind of fluid. So it will be rise. So it will be rise. So during the rise of this fluid, how much the heat energy will produce in the tube? और ये assume करना है आपको थीटा वैल्यू जो कॉन्टेक्ट एंगल है ये 0 है ग्लास वाटर सिस्टम के लिए एंड rho is the density and sigma is the surface tension. My dear, again I will give you 1 minute for thinking only. So I will give you 1 minute. Time's up. Okay. Now, start with this problem. This is also, so this is problem related to the capillary, but there is a very good concept in this one. Okay. So what is that? There is a capillary tube is there. You know that this is a capillary tube. There is a capillary tube. Okay. This is your capillary tube, and this capillary tube is immersed into the water bath. It will be immersed in water bath. This capillary is immersed in water bath. Okay. This capillary is immersed in water bath, and we know that the contact angle of the water, that means wetting fluid, is less than 90 degree. So it is like that, free surface. It is like that. Why? Because this is your water. So these are the free surface. Okay. Now this is your water. Okay. This is your water, and let's suppose this mercury will rise up to height h. So this is your height h. At this point, this will rise at this level. So this much of height of the fluid will be rise in the mercury, in the column, capillary tube, and this tube of a radius, this radius is your r. R is your radius, it is given. R, radius r. Okay. Here theta it is given, contact angle 0 degree, sigma surface tension, and rho is your density. It is given. So in this fashion. Now my dear, what is the concept? So what is that? If you dip this capillary tube inside the water will be rise up to height h. So during the rise up, what is the heat loss? During rise up, what is the heat loss? What is the heat loss? See my dear, there is a one thing is very important. If there is a something loss, then we have to provide something. Now my dear, this much of the fluid element, let's suppose you have to write like that, this much of the fluid element, this much of the fluid element, let's suppose this much of the fluid element will rise, yes or not? This much of the fluid element will rise inside the approximately this much of the liquid will rise inside the capillary tube. So this have a mass, this chunk have a mass, this chunk have a mass. So this mass will travel from this h equal to 0 to h is equal to h. This much of this mass will be displaced. So there is a body, and how much displacement? H. So that displacement into the force, work done. That displacement, this mass, this chunk of the mass, mass of fluid rise. This chunk of the mass of the fluid will rise up to height h. So during the rise up, it is moved at a displacement h, multiply with the viscosity, multiply with the force, that is a work done, which is, there is a work done required. How much the work done required? The work done required to move this fluid, this mass of the fluid up to height h. That is your input work, number first. Now my dear, this input work, what is the input work you are giving? Work done. And what is the work done? Force into this displacement. So this work you are giving to the system. This is our system. So this work you are giving to the system, and that energy, work is a form of energy. So that energy will convert it into further two form. That means what is the work input, work energy you are giving, that work energy will convert it into two parts. First part is to rise the height up to h of the mass, that is the potential energy, plus heat. Plus heat. So that work, what is your input and that is the output, it is a two form, potential energy. The work you are giving, so mass will rise, that is your potential energy, plus while it is moving there is a heat loss. So heat loss plus potential energy is output, or input is what? Work done to displace the fluid up to height h. यहाँ तक clear हुआ? Please tell me. Up to that there is any confusion? Please reply. Okay. So my dear, done. Now, so what is this? We know that. What is the height of this capillary? H is equal to 2 surface tension. This is coefficient of surface tension, cos theta by rho g into r. We know this thing. This we know. This we know that H is equal to 2 sigma cos theta by rho g r. Now, so total work done to rise up to h. Total work done to rise up to h. So this work done, and it is input energy. Yes or no? To rise height h. That is what a force into displacement. Now my dear, what is this force? Who is responsible to rise this height? Who is responsible? This force. And this force is what? Surface tension. So this is what? Surface tension force. This is your surface tension force. Now, surface tension force is what? Line force. It is a line force over the line. So we know that coefficient of surface tension is surface tension force divided by length. So here, what is the surface tension? Force sigma into L. This is your coefficient of surface tension. Coefficient of surface tension. This is your line, yeah, perimeter, okay, over this length. Now, so here, see this thing, the surface tension here, this is the surface tension. So in this direction, there is a surface tension coefficient. This is, let's suppose, okay. So this is done. So this is sigma, yes or not? Let's suppose this is sigma, and this sigma have a two component, vertical and horizontal. Horizontal will cancel out. It is like that, na? You know this thing, I know that. It is like that. So all around, there is a sigma. All around. So it is an incline. So the vertical component is balanced by weight. This weight is balanced. So this is, what is the vertical component of this thing? So this is your contact angle, we know this thing. This is our contact angle, theta. This is our theta. Contact angle beta always measure from the surface to the tangent in the fluid side. So this is also theta. So this upward is what? Sigma cos theta. So what is the surface tension force? F. F is what? Instead of sigma, you have to put sigma cos theta into L is what? 2 pi r. this is your L. Okay, 2 pi r over the cross section. Now, so my dear, what is that work done then? That means work done is equal to sigma cos theta into 2 pi r, yes or not, into h is there na. So work done is equal to sigma cos theta 2 pi r, and h is what beta? 2 sigma cos theta divided by rho g r. It is visible? Okay, we'll change the color, no problem. Okay, now my dear, see this thing, this r is cancel out. So what is the work done? So work done to rise the fluid up to height h, that is your, if you solve, this is your 2 into 2, 4. So this is a 4 pi sigma square cos square theta divided by rho into g. This is your work done, and this work done is input. You are giving the work done. This is your work done. This is your work done. Now, this work done have going into two components. First one is the rise in potential energy. Rise in potential energy. Rise in potential energy, and second, heat generation. Second, heat generation. This work input will be two part rise in potential energy and heat generation. So first we have to calculate rise in potential energy. Rise in potential energy. Now what is that? How to write potential energy? What is the potential energy? Please tell me. What is the potential? How to write the potential energy? 90% student here confusion. 99%. What is the potential energy here? Please tell me. Potential energy mgh. Potential energy mgh. Yes. H height, but the h is h by 2. Potential energy measure from datum to the. Let's suppose this is your body. This is your body, and this body, it is your h height. So h always measure from the CG. H always measure from the CG. So how much it is? mg h. But here where the CG? CG is your h by 2. CG is your h by 2. So how much it will rise the potential energy? mg h by 2. Very good. This is your CG. mg h by 2. How much the CG? This is CG. How much the CG will rise? H height. So this is h. How much the CG? This fluid element, this chunk of the fluid element. Where the CG? This CG. So how much the CG will rise? H by 2. Don't confuse. So here, this is your mg h by 2. CG will rise. From the base to the CG will rise h by 2. Okay. So why? Because CG at h by 2. Okay. So beta, what is the mass? Density into volume into h by 2. Okay. So volume is what? Okay. So density into volume into g. Into g. So density into g. What is volume? What is volume of this chunk? Cylinder, na? This is cylinder, na? This is cylindrical shape. So what is the volume? Pi r square into h. Pi r square into h, this is your volume, into h by 2, into h by 2. Put this value back here. So rho g pi r square divided by 2 into, that is your h square. So h square value 2 sigma cos theta rho g r whole square. So potential energy is how much? If you arrange this r square, this r square, this r square cancel, and many things is cancel out. So this is your 2 pi sigma square cos square theta divided by rho into g. This is your potential energy. So this total energy will convert it into rise in potential plus heat loss. So work done is equal to potential energy plus heat loss. Yes or not? Heat generation, and that generation it is converted into loss. What is the heat generation? What is the meaning of heat generation? Any the mechanical energy, any form of energy, if that form of energy will convert it into the thermal energy, if any form of energy will convert it into the thermal energy, there must be a generation. So heat loss is equal to work done minus potential energy. So what is the work done? 4 pi sigma square cos square theta divided by rho g minus, what is potential energy? 2 pi sigma square cos square theta divided by rho g. Now my dear, simple. So what is the heat loss? Heat loss is equal to simply 2 pi sigma cos square theta, just half. So this is your 2 pi sigma square cos square theta divided by rho g. Now my dear, here theta it is your 0 degree, yes or not? 0 degree. So this 0 degree is your 1. So heat loss is what? 2 pi sigma square divided by specific weight divided by specific weight. Clear? Clear or not? Please tell me. This is clear or not? Please tell me. Clear na? How to find the heat loss, that is clear. Very important, I am telling you. So this concept is the question is very unique, I am telling you. This question is very unique. All the question is very unique. Just try to solve this question, okay? Now, next question. What is the next question? Please read this question. The question is, if a hole is made, in the torsionally vacuum portion of the barometer, there is a barometer. If you put the hole in that barometer, then the mercury will be, what is the option? Level will fall in the steam and the mercury will be collected in the reservoir. Level will oscillate between the reservoir level and the original level of the mercury in the steam. Will split throughout the hole made. Level in the steam will remains at the same level, indicating atmospheric pressure. Okay, so this is also a very good question. Now I will give you a timer for 1 minute. Start. Time up. Sorry. Now let's start this problem. Okay. So this is a tortoisely simple barometer. This is a simple barometer. What is that? There is a container. In this one there is a Hg. Mercury is there. Now there is a height h. We arrange something different according to the question. Obviously this is atmospheric pressure. So pressure at B is equal to pressure at C, same level, same fluid. Pressure at A may be 0, may not be 0, depending upon the fluid properties. Okay. So let's start this one. So this is your, one second, yes. So my dear, let's assert this is your container. It is visible, yes. This is your container, my dear. In this container, there is a tube. Okay. In this one, there is a Hg. Let's suppose this is Hg, and let's suppose this Hg will rise up to this level H. Let's suppose this level H. Now my dear, we create initially there a vacuum. Let's suppose here we add a tube, and through this tube we create a suction effect. We create a suction initially vacuum. Initially vacuum. Initially vacuum. Okay. Now, so this says that a hole is made into a vacuum portion. So we have to create a vacuum here. We have to create a vacuum. So what happened? There is any fluid, the property of any fluid, what is the one property of the fluid is very unique property. What is that? Any fluid at any temperature, there must be evaporation. Any fluid. So there is evaporation will take place. Okay, and after that it will fill inside this vacuum portion, and then at equilibrium it will be apply pressure on this mercury column. So this is what PV of Hg, vapor pressure of Hg. So if you write the barometric equation, PV of P Hg vapor down plus rho of Hg into G into height h, and that is equal to, there is atmospheric pressure at this point and this point are same. See, at this point and this point are same. So this is your P atmosphere. Clear na? That means P Hg vapor minus P atmosphere is equal to this or gamma of Hg into H. Now my dear, the question says that if you made a hole, that means you create a hole in this portion, you create a hole. Why? Then what happened? This is a vacuum, so the air will rush. That means the fluid, some fluid, air will rush into it. Rushing. Why? Because this is a vacuum, low pressure. This is atmospheric pressure, high pressure. So fluid will be inside through this hole into the vacuum portion. So what is happening then? Then vapor pressure will increase and it will be equal to the atmospheric pressure. What is the outside pressure is there? That means if you made a hole, this P Hg of vapor will equal to the P atmosphere through hole. That means rho of Hg into H is equal to 0. That means H is equal to 0. After you putting the hole into the torricelli, this is a torricelli device. That means if you put a hole in this zone, if you put a hole in this one, okay, then the outside fluid will come and inside it will be atmospheric pressure. So this atmospheric pressure is there. So this H height is 0. H height is 0. That means all the fluid come into the reservoir and it will be settled down. That means there is no any, if you put a hole, there is nothing story of H. That means all the fluid will be fall down. All the fluid will be fall down. So what is the option? The level will fall in the steam. This is your steam. This is called steam. In the steam, level will fall down in the steam and the mercury is collected. Mercury is collecting in the reservoir. And this all the mercury are collected in the reservoir. So which option is correct? Option A. Clear? Clear na? Explanation. Why? Because this type of question, student confused. Simple question, but the student confused at this junction. This is clear, beta? Done na? So level will fall down and it will be collect into the reservoir. It will be collect into the reservoir. Okay. That is done. Now next problem. Yes. Simple problem. Again. Please read this question. A inverted U-tube manometer is used to measure the pressure difference between the pipe A and B as shown in figure. Pipe A is carrying oil of a specific gravity 0.8 and pipe B is carrying water. The density of air and water are 1.16 kg per meter cube and 1000 kg per meter cube respectively. The pressure difference between A and B is, and it is given acceleration due to gravity is 10 meter per second. So my dear, again I will put the alarm. I want to put the alarm. Start. Time up. Okay, we'll discuss this problem. So this is called inverted U-tube. This is inverted manometer. Inverted U-tube manometer. Okay, simple, very simple problem. This is air and the air density it is given. In this one there is air, this is oil, this portion there is oil, and in this portion there is a water. This is water. We have to find the pressure difference, magnitude PA minus PB is what? In magnitude. Okay? So we apply the manometric equation, simple, we apply the manometric equation. So here the pressure is your PA, and this pressure is all about the same. So here it is the pressure PA. Now you are moving up to this height, so this is a negative. So we'll write PA minus density of oil G, and H is how much? This 200 divided by 1000. Why? Because this is mm. Now you are at here. Now you are not, my dear, some student jump here. This is the same line, so they want to jump. It is wrong. See, jumping or the same horizontal line, the pressure will same only if the fluid is same. So my dear, if you jump from here to here, here is the fluid is oil air interface, and here it is only water. So that is wrong. So you move up again. So you move up again. So again you move up to this height, 80. This height is 80. So minus which fluid? Air. G 80 divided by 1000. Now you want to jump, no problem. From here, why? Because if you jump, this fluid are same. So your jump here. Now again, the all fluid are same, so you are at here. This is point B. So minus, this is a plus. In which fluid? Water. G. What is the height? 80, 200, 100, 380 divided by 1000. And now you are is here. So what is the here pressure? All the pressure are same fluid. That is equal to PB. That is equal to PB. So put all this value back here. We have to find. So PA. Now minus density of oil. A specific gravity it is given. Specific gravity, I think it is given, oil 0.8. So 0.8 into 10 to the power 3. Okay, G you have to take outside, no problem. Into 10 into 200 divided by 1000, 10 to the power 3, minus density of air it is given 1.16 into, no, not into, into 10. This is your 80 divided by, please try yourself also, don't watch, you are looking only. अरे please पेन पेपर लीजिए और सॉल्व करना स्टार्ट कीजिए. प्लस वाटर 10 to the power 3 G 10 380 divided by 1000. Very simple problem. It's equal to PB. So PA minus PB, if you find, that is your minus 2.199 kilopascal. But they are asking magnitude. So magnitude of PA minus PB is equal to 2.19 kilopascal. Correct? Correct? So this is the simple problem. So accordingly you have also, what is the motive of this lecture? The motive of this, see, it is not like that there is a magic. The motive is that try to solve similar kind of problem. More chance, there is a more chance the question will appear in this upcoming GATE examination. There is a more high chance. So try to practice according to this series, otherwise very difficult. Okay. Now, next question. Yes. Next question. Please try to solve this question also. What is that? An inclined tube manometer. There is an inclined tube manometer beta. This is your inclined tube manometer. Measure the gauge pressure PS of the system S. Figure given. The reservoir and the tube diameter of the manometer are 50 mm and 5 mm respectively. The inclination angle of the tube is 30 degree. Inclination angle. What will be the percentage error in the measuring system pressure if the reservoir deflection is neglected? Very important. If the reservoir deflection is neglected. See, my dear, this is also very good problem. Reservoir. So again, just try. I'm not. I'm not supposed to that कि you have. मेरे को ऐसा नहीं है कि आप इसको solve कर ही दे. नहीं, आप try कीजिए इसको 1 मिनट के लिए. Please try it. Okay, time up. Okay, this is also very good problem. Okay, now, so what is the approach? Initially, what happened? This was inclined tube manometer. Let's suppose initially this is also open to the atmosphere. And obviously this is also open to the atmosphere. So initially this is your level, this level. Initially this is your level. Initially this is your level. Initially this is your level. This is your initial level. When we'll increase the size, no problem. This is your initial level. When both end the same pressure. Here it is also atmosphere, here it is also atmosphere. Let's suppose there is this is not there. This is not there. Let's suppose this is not there. So what is the pressure at here? Atmospheric pressure. And what is the pressure at here? Atmospheric pressure here. So line is initially there is a same line. Okay. Now the second stage is that you connect the bigger reservoir to the system. You connect the bigger reservoir to the system. This is very important, I am telling you. Connect the bigger reservoir to the system. This area is A. This area is your A, capital A, and this area is the cross-section area is small a. And this capital A is very, very, very higher than A. This is a reservoir. Now, my dear, if you connect this reservoir to the system, system will exert the pressure to the fluid. System will exert the pressure to the fluid, and this side is open, so obviously this fluid will deflect down. Let's suppose this deflect down by distance y. Distance y it will deflect. So if this deflection down is here, now there is a deflection. Now this is your deflection. So this is your deflection down. This is deflected down. Let's suppose this is deflected down at a distance y. So from this one it will rise up to this height, up to this length, along this length, and there is a reading. There is a reading. Now my dear, if you measure the pressure, pressure always play the vertical role. So what is this component? R sin theta. Theta is the angle, 30 degree it is given. What is the question they are asking, sir? Please tell me, see this. What will be the percentage of error? How much the error will found? How much the error will found, my dear, when reservoir deflection is negligible? That means if you take y tends to 0, how much the error you have to find? And why this y tends to be 0? We are bothering why y tends to be 0. Why? Because beta, this is the inclined tube manometer, which is the device which used to measure the pressure when one end is not transparent. Let's suppose this is your concrete. This is your concrete. So how much this y will be deflected while putting this reservoir into from the system? You are not able to see this y deflection. मैं फिर से बता रहा हूं, इस कंटेनर को कंक्रीट से बना है, लेट्स सपोज, और उसको इंस्टॉल कर दे सिस्टम में, सिस्टम विल एक्सर्ट्स ए प्रेशर, सो देयर मस्ट बी डिफ्लेक्शन, बट फ्रॉम द कंक्रीट यू कैन नॉट एबल टू सी what is the deflection. So you assume that deflection is 0. You cannot see. So if assumption y tends to be 0, how much the error will take place? While measuring, how much the error will takes place? That is the question. Clear now? Clear? Okay. Let's try. Let's try. Now my dear, this is your one second, I will take different color. Okay, no problem. Okay, so this is your initial. This is initial. When this is initial, when there is a both pressure same, both in the pressure are same. Let's suppose that means initial level. This is your initial level, my dear. Initial level when no pressure is applied by the system. That means both side open to the atmosphere. Both side open to the atmosphere. Now, correct? Now, if you reservoir side you connect a system pressure, so obviously system pressure is higher, so water level will depreciate with this amount. Let's suppose this amount, the water level will depreciate. Let's suppose this amount. And let's suppose this is your my dear, this distance is your y. So this is your final level, this is your final level when pressure applied, when system pressure will applied, and this level is your y. Clear? So if this level will rise y, there is a reading. So in this reading, in this inclined, there is a traveling of the fluid at a r. So r you can measure. Now my dear, so r sin theta. Okay. Now my dear, see this one. If you calculate this y, how to calculate this y? Volume. See, mass flow rate. What is the mass flow rate here and what is the mass flow rate here? Volume flow rate, mass flow rate, density, area, velocity. Density, area, velocity and density, area, velocity is same. So volume, that means capital area into displacement is y. Small area into displacement is how much? R. Yes or not? R. So from here, what is y? A by capital A into R. Now my dear, see this thing. A is very less than capital A. So A by A we can neglect. So in that sense, y we can neglect. Yes or not? With this we can neglect. This we can neglect. So in this sense, y tends to be 0. So if y tends to be 0, how much the error you have to found? Okay. Now, so my dear, let's suppose the pressure at P, this line, the pressure at P, this point pressure, and this horizontal portion, this is a horizontal portion, no? This one. After deflection y, let's suppose this point pressure and this point pressure are same horizontal line. So let's suppose this is P and let's suppose this is Q. Okay. So pressure at P is equal to pressure at Q. So pressure at P is pressure at P, and what is the pressure at Q? Pressure at Q, rho g, and this height r sin theta into plus y, r sin theta plus y, yes or no? So this is pressure at Q is what? Pressure at Q. So here, what is the pressure? Let's suppose this is pressure at B. So pressure at B at here plus this height. So pressure at Q is equal to what? Pressure at B plus rho G into H. H is what? R. Vertical distance always taking. Sin theta plus y. Yes or not? R sin theta here. This height. So this is your r sin theta. This is your r sin theta and plus y. Vertical depth. So from here, pressure at P minus pressure at B is equal to r sin थीटा को कॉमन निकाल लेंगे आप, तो क्या मिल जाएगा आपको? 1 प्लस y बाई r sin थीटा इंटू rho m into g. Yes or not? Yes or not? Now, so this is done, r sin theta. Now, here instead of y we put a by a into r. So, p at p minus p at b r sin theta 1 plus y is what beta? A r by capital A r sin theta into sigma m into g. Yes or not? R cancel. So A by R sin theta sigma m, and this is beta what? PA minus PB. This is what? Actual value. Yes or not? This is what? Actual value. Actual pressure difference. Why? Because we are including y value. No. But if you neglect y beta, so this is what? If you neglect y, so P minus, so this is your, if y tends to 0, so what is this? PP minus P of B, that is equal to r sin theta rho m g into g. R sin theta rho m into g, and this is your theoretical, not actual. Why? Because actual y is there now. So difference between this, अब देखिए बेटा, see here, this a by r and this is your r sin theta. Now if you take the percentage of error, so this is your measured value. Measured value you can measure. Why? Because here, why measure? Why? Because this is beta actual, but this is your measure. Why? Because you can measure this value only. Why? Because this is the non-transparent. This deflection is very minimum. So you can measure this r. So while we are neglecting this y, this is a measured value. So percentage of error is your actual pressure minus measured pressure divided by actual pressure into 100. Put all this value, that is your 1 divided by 1 plus, if you calculate a by a sin theta. If you put all this value, delta PA, this is your delta PA, this is your delta PA. Delta P is what? R sin theta into 1 plus a by a sin theta rho m into g, and this is your delta PM. This is your delta PM measured value. If you divide, this is your, now each and every value it is given. 1 divided by 1 plus a 52 whole square sin 30 degree. If you solve into 100, if you solve it out, this is your 1.96%, and this is error. And my dear, in the engineering, less than 5% error we can consider. We can consider no problem. If the error is less than 1.5%, there is no any problem. So my dear, if you neglect that, why this much of amount of error you have only found? So that is the importance of the inclined tube manometer. That is the importance of inclined tube manometer. That's why we can, without seeing this value, how much it will deflect, only reading this R value, we can easily calculate what is the pressure difference. Clear? Clear, na? Clear? Okay. Now, so this is the related to the pressure measurement. This is related to the pressure measurement. Now, my dear, the next portion is, one second. The next portion is, okay, pressure measurement done. Yes. Next is your related to hydrostatic. Next is your related to hydrostatic, my dear. So this is the question of hydrostatic. See this thing. Okay, this is the hydrostatic question. What is that? A 5 cross 5 mm closed tank. A 5 cross 5 meter closed tank. So this is a closed tank, my dear. Okay. This is your closed tank. So 5 into 5. Okay. This is a closed tank. This is a closed tank of 10-meter height. 442. Contains water and oil. Water and oil. Is connected to a overhead water reservoir. So this is overhead water reservoir. This is your water reservoir. Overhead. Yes, overhead. Overhead water connected to overhead water reservoir. Okay. As shown in figure. Figure दिया गया आपका पास. Specific weight of the water it is given, that means rho into G is equal to 10 into 10 to the power 3, it is given. It is given. And a specific gravity of oil, S of oil it is given, that means this is your 0.8, it is given. So density of oil you can find 0.800, 800, okay, kg per meter cube. You can easily find. Okay, they are asking that the total force in kilonewton due to the pressure on the side PQR. This side, what is the total pressure of the due to this combined system of the tank? Okay, done. So, my dear, I will give you only 1 minute. Please try to solve this question. Okay. Please try to solve. Start. Okay, so time up. My question is that what is the first approach? Everyone, what is the first step? What is the first step? The first step is that this is a closed, that means this is this container is pressurized. This is your pressurized container. So hydrostatic force on the water, hydrostatic force due to the water and hydrostatic force due to the oil, but here it is a close, and we know that the hydrostatic pressure rho GH and H is always from the free surface. Clear na? So what is the hydrostatic pressure? P is equal to rho GH, and this H is always from the free surface, from free surface, from the free surface. Now my dear, think one thing, but there is a no free surface, this is closed, so no free surface. So there must be a pressure at this point. There must be a pressure at this point. So first find the pressure at point R. At point R. First find the pressure at point R. Okay, done. Before that, there is one thing also, there is mistake in the student. Why? Because the G, what value of to G put? So some student says that, sir, there is nothing to mention here, the value of G. So we can take the G 9.8. If you take 9.8, there is wrong. Why? Because here rho G it is given. So rho 10 to the power 3. So rho is equal to 10 to the power 3. G, that is equal to 10 into 10 to the power 3. This 10 to the power 3. So G is equal to 10 meter per second square. G, we will put 10 meter per second square. G how much? 10 meter per second square. Okay, that's it. Now, simple. So my dear, we have to draw this diagram again. Okay, it is there, no problem. Now, the thing is that we have to find what is the pressure at point R. Pressure at R. Okay, what is the pressure at R? So pressure at R, how to find pressure at R? How to find pressure at R? See my dear, this point pressure you can easily calculate, no problem. Let's suppose this is Q dash. This point the pressure you have, what is that? Rho G 10. And this is same level, same level, same level, same level, same fluid. That is the pressure of Q you can easily find. That's why this overhead tank it is given in the question. Otherwise, very difficult to find. It is not practically find out. So this is pressure P at Q dash is equal to rho of water G height 10. Yes or not? And this P at Q dash is equal to P at Q. And what is the P at Q? P at Q is equal to P at R plus rho of oil G. What is height? 4. So P at Q you have, you can easily find P at R. Yes or not? You can easily find P at R. So from here, if you find P at R, so what is that beta? P at Q dash is equal to P at Q is equal to P at Q, and that is equal to pressure at R plus density of oil G and H is equal to 4. Okay. Now pressure at Q dash, density of water G into 10. Yes or not? This is 8 plus 2, 10 is equal to pressure at R plus density of oil G into 4. Okay. Now, so if you find density of water 10 to the power 3 into 10 into 10, pressure at R, density of oil is 800 into 10 into 4. So if you solve this one, 800 into 10 into 4 PR, this is 10, 10 to the 10, 10. So if you solve, the pressure at R is equal to 68 kilo. This is the first, this is your first thing, please mind it. This is your first step of this question. If there is any pressurized tank is there, if there is any pressurized tank is there in the hydrostatic calculation, just you have to find pressure at R. That means pressure at the closed surface. So this is the pressure. Now my dear, that means this is not a free surface. Now that means if you draw the pressure distribution, if you draw the pressure over this surface, see my dear, this is our surface, very important, this is our surface, yes or not? Okay. So this is our surface, okay, this is our surface. What is the pressure at this point? 0? No. Why? Because this is closed, pressurized. What is the pressure at R? 68 kilopascal. So here is the pressure. How much? 68 kilopascal. Okay. Now you are moving down. Yes, you are moving down. The pressure will vary linearly and increasing nature. So here is the pressure at P, which is higher. Yes or not? This is pressure at P. Now you can join this line. Now you can join this line, my dear. So this is a pressure variation. This is your pressure variation. This is your pressure variation, my dear. This is your pressure variation. This is your pressure variation. Okay. Now, my dear, see this thing. This is your pressure variation. Okay. This is your pressure variation. Now, see this thing. Think very important. If you draw a line from here, so this is throughout the pressure is this section, throughout the pressure is how much? 68. So this 68 pressure throughout this much, and this is due to the oil. This is due to the oil. Now this is due to the oil. So throughout this is due to the oil. This is due to the oil. Now this extra portion, very important. This extra portion, my dear. This extra portion. This extra portion. This is due to the water. Why? Because beta, this water is a pressurized. This water is a pressurized. So how this water is there? So how much the oil will create the pressure on the water? This much at this surface. Then how much the water will create the pressure on this surface? This much. So this to this. This to this, my dear. This is due to the water. And this is due to oil. This is due to oil. This is due to the water, black chunk, and this is due to the oil. Obviously, this is due to the oil also, triangle. So if you find the net total force due to this pressure variation, total force due to this pressure variation on the plane PQR, we have to find deal with the pressure prism diagram. What is the pressure prism concept? There are two concepts. One concept is that what is the volume of the pressure prism is your hydrostatic force on the plane surface. What is the volume? The same volume will deal as a hydrostatic force, number first. So if you find the volume of this pressure prism, that volume is the net hydrostatic force on PQR, that is a plane. And the second thing, where this net hydrostatic force will pass? The net hydrostatic force will pass, very important, at the CG of this pressure prism. So there is a pressure prism. Calculate the volume. Calculate the volume of this pressure prism. The pressure diagram. Calculate the volume of the pressure diagram is nothing. It is the hydrostatic force on that plane. Second. Number third. Calculate the CG of this pressure diagram. Calculate the CG of this pressure diagram. That is the center of pressure of that hydrostatic force. Two things always remember. So then all the things is clear now. So due to the water, how much pressure will there, beta? Due to the water, how much the pressure? Please tell me. Due to the water, rho of water, G, and this height. This height is what? 8. Yes or not? So 10 to the power 3 into 10 into 8. How much it is, beta? Into 6, not 8. This is 6, beta. This is 4 plus 2, 6. 4 plus 2 is 6. 6. So this is how much? 60 kilopascal. So total pressure on the base is 60 plus 68. Clear, na? Now, so this is due to the water. And due to the oil, this is 68. Okay. Now, my dear, net force, F, net hydrostatic force is what? Volume of pressure diagram. Volume of pressure diagram. What is the volume? This is what, beta? This is your trapezium. Yes or not? Yes or not? Summation of two parallel plus the gap. So first trapezium due to the aisle, you can take like that, no problem. And second one is this one. So this is due to the aisle, pressure of diagram, this is due to the aisle, and this is water, to pressure prism in the pressure. So what is the area, beta? Area half into 68. This is 68 plus this is how much? This is how much? 100. 1 second. PB. 1 second. This is how much? See, this is your this much. This is how much? 68 and plus this is 100. 100 into this distance 4. इसमें आ जाओ 100. अरे यहाँ 100 निकाला ना. प्रेशर एट क्यू. प्रेशर एट क्यू कितना है? सी प्रेशर एट क्यू कितना है? प्रेशर एट क्यू. सो प्रेशर एट क्यू इज इक्वल टू 10 to the power 3 rho g 10 into 10. So this is how much? 100 kilopascal. So at this point, what is the pressure? 100 kilopascal. So this is 100 kilopascal. 100 kilopascal. This is 68, and this is how much? 60 plus 68 is how much? So this total is 100. Let's suppose this total is 100. Oh, this is 100. No, it is due to the aisle. 1 second, beta. This is wrong. 1 second. This is due to the aisle. Here, from up to here. This is due to the water. And this is due to the aisle. This is due to the aisle. So water, it is what? Rho g into h, no problem. So this is water. This is for water and this is for oil. Why? Because oil 100. So this is for oil. No problem. First trapezium half 68 parallel side plus 100. 68 plus 100 into distance 4, this is area. Second, plus half into 100 plus 100 plus 100 160, 100 plus 160, 100 plus 160 into the gap is 8. Okay, and then in total, this is area, trapezium area. What is the trapezium area? Don't confuse. If this is A, B, this distance is your H. So what is the area? Half A plus B into H. This is the area. So half A plus B into H, half A plus B into H. So this is area into width. Width is how much, beta? Perpendicular 5. Perpendicular 5. Now if you calculate, this is your 5580 kilonewton. 5580 kilonewton. So what is the moral of the story is that don't confuse with that there is a no pressure. This is a closed tank. So closed tank, what is the pressure at this point? You just calculate. Just calculate. Okay. So my dear, some more problem is there. We will discuss that more problem. What is the कुछ extra problem और है मेरे पास. जैसे कि ये very good problem is there. Very good problem. But there is a time constraint. So we'll discuss, I think, no problem. In the 5 minutes, we can discuss. So what is the answer? Please tell me. What is the answer of this thing? Please tell me. Who is watching? Please tell me. What is the answer in this one? See, my dear. Why this column I will take? This is the, obviously this is already asked in the gate. But this case questions, I know that in this question there is a many concepts. See, my dear. If you just apply the hydrostatic, what is the force? Pressure into area. What is the pressure here? Rho G into capital H into area of this A. That means what is the pressure here? Rho G into H. Yes or not? At this platform. So what is this F? Balance. Rho G into capital H into area. This is answer. Rho G H capital N into C. But there is no problem. But my dear. So this is your pressure force. Now, if you calculate what is the weight of this fluid, what is the weight will exerts by the fluid. Yes, this is the weight. And weight into area. Weight into area also pressure on this platform. But these two values differ. Understood or not? This is from the hydrostatic. Now, if we calculate the weight on this platform, if you calculate this weight on this platform, that weight is exactly equal to F. That weight, this weight, if you calculate the weight, and that weight is equal to F. So the answer will same rho G H, but there is a difference in answer. If you calculate like that, the answer it is like that. Rho G capital H A, okay, no problem. It is like that, beta. So it is not like that. If you calculate by the weight, so weight it is your not equal to force, and that is equal to beta rho G A H A minus capital A minus a small a into H. This is so, and only there is this part is only the answer of this thing. So if you calculate the weight of this fluid, and that weight is equal to the force of this force. So in that sense, the force will reduce according to this value. This value is rho g h into a, and here rho g h a into a minus of rho g capital A minus. That means this W will less than the pressure force. The question is why? The question is why not the same answer? Why not the same answer? Yes, if I am standing on the platform, so what is the weight of my platform? What is I will create the weight on my platform? That weight is balanced by this force. There is nothing problem in this case. And if you calculate with the help of hydrostatic force, that is also true. That is also true. अरे हम जितना प्लेटफॉर्म पर खड़े हैं वो वेट यही फोर्स बैलेंस करेगा, तो वेट निकाल दिया. So that is the force. Now according to hydrostatic force, this is a force. So why these are difference? Why this is differ? This is due to this problem is from hydrostatic paradox. This is your hydrostatic paradox. So whenever there is things is there, just you calculate the hydrostatic force. That's it. Don't confuse with this, weight is equal to. So weight, there is nothing. Weight is not a hydrostatic force. Clear now? So my dear, we'll discuss this problem tomorrow also, no problem. Tomorrow at 5 to 8 p.m. again we will discuss, and tomorrow's session is very, very important as compared to today's lecture. Why? Because tomorrow we'll discuss very advanced problem. Okay. So there is one announcement again. I will just tell you. This is your again I will tell you, beta, my dear. Okay. So this is what test series plus. There is a one announcement, test series plus. What is the test series plus? So already the benchmark yourself against the best test series plus is that by this will be created by the IITs and NITs. In this one you have a 130 online test, 33-year PYQ technical book is there, and this technical book there is a QR code, so you can directly scan the QR code और आप उसका video solution पा जाएंगे. So that is very unique features. And also बेटा 33 year of GATE PYQ book है जो separate है. That is the separate from the technical book. That means there is a 2 different books. जब आप एडमिशन लेंगे तो आपको 2 different books available होंगे. One is the complete 33 year का आपका technical and 33 year का math plus general aptitude. And this is also very good. Math plus aptitude is also very good solution. Okay. फिर doubt solving portal आपको मिलेगा. There is a doubt solving portal, that is LMS. That means you can paste, if you have any problem in this regarding, you can paste directly on the doubt problem within 25 or you can get best solution. Now online revision and score booster is there like that. Post GATE guidance also there, and also there is we conduct the interview after the crack any competitive examination, and if you are entering into the interview, we also guide them. Now this is more about the online program. If you join live online program, what you have the features, you can get the मतलब अगर आप live online program को join करते हैं तो आपको ये सब features मिलेंगे. What क्या है? 800 plus hour live classes with the live interaction. Also you can get theory book, exercise book. In that theory and exercise book there is a 4,000 plus questions is there, and then 34 plus, this is not 34 my dear, okay na? This is by mistake. This is 33 year GATE question bank with video solution. Okay. Now 12 personalized one-to-one mentorship session is there. That means one student interact with the another one faculty. One-to-one session is there. Okay. Kitna 100, 12 and 130 online test with the video solution of mock test. That means अगर आप online test देते हैं और उसका अगर questions आपको solution चाहिए, video solution मिलेगा, so that you can better understand. Okay. So I request you that if you want to free counseling, if you want to know that more about more features, you can click this. You subscribe this that means click that link below description. This is the link, or you can call directly the counselor team. Give you a better idea about that. Okay, done. And this is very important. This is free of cost, no problem. This is a Telegram group channel. In this one, there is a schedule of free YouTube lecture. That means there is any plan of YouTube lecture, or that update you can get, and all the today lecture. What is the today lecture is there? That PDF you can get. Important update related to the seminar, webinar, and also PSU's another government job notification latest, and expert session on important topic. That means there is some important. Let's suppose in fluid mechanics there is I thought that कि कोई टॉपिक मेरे लिए बहुत इंपॉर्टेंट है, तो उसका हम एक सेशन लेंगे. ऐसे चलते रहता है. डेली क्यूज होगा उसमें, वेरी गुड क्वेश्चंस एंड मेनी मोर. सो इफ यू ज्वाइन, दैट इज आवर link, so you can join the Telegram group channel. Okay, my dear. Now then, that lastly slide. Thank you. Bye bye.